Okay, so hi, my name is Olivia.
My name is Tara.
I'm Sky.
And our presentation today will be on photolithography. So just as a basis, lithography means the transferring of an image from one surface to another, but specifically photolithography is using light to transfer to the image to a light responsive surface. And so, okay, basically as a summary, lithography means patterning. And just as like a tension reliever, I'm going to say a joke about light particles because I can feel like the tension here and it's really bad. So yeah. Okay. So a photon enters into a hotel room and checks in, and the clerk asks, "What can I help you with?" But the photon says, "I don't need any help. I'm carrying light." Okay. Okay. Sorry. Moving on. Okay, so you're probably going to ask, what does photolithography have to do with my life? It's actually really like applicable to every aspect of your life, whether it's biological, medical, or like your everyday applications like your phone. It's in every part of your life. And just as another basis, we're going to say the 6 steps. So the first step is coating the photoresist. So the first step is having the base layer, which is the substrate, and then you're going to coat the substrate with the photoresist, and then afterwards you're going to align the masking, and then the third step is exposing it to UV light, and then you develop a resist pattern after that. And then the 5th step is etching, which is removing any unnecessary particles, and the last step is stripping, which is when you clean the photoresist off.
Okay, so I'm going to be talking about our lovely drawing. So here we have, it's basically an arts and crafts project. So you can see the first rectangle there is a piece of paper, and that we believe represents the substrate or the base layer. And then as you can see, it goes on to the glue being squirted out into the design of a face, and we believe that was representing the photoresist and also the masking. And then you can see glitter is poured on to the whole paper, and we interpreted the glitter as the UV light, such as like when it's being exposed. So the glitter is the exposure, and then you can see that in the last piece of paper, it's all the glitter that was on the paper is gone. So it's just the remaining glitter is on the glue, and that represents the etching step, which is getting rid of the unnecessary particles. But as you can see, the first has too little glitter, which basically represents the underexposure of UV light. So there was not enough UV light getting to the glitter, basically. And then the second part represents a perfect sample with a perfect amount of light. And the third sample is overexposure, which is too much UV light.
So I'm going to be going over some other science concepts that we did in this lab and some suggestions maybe for additions to the photo. So basically one of the key aspects of lithography or photolithography is for technology. And another thing with that is making it smaller and smaller and smaller. So you can fit more things on a circuit chip, so you can store more information and make things smaller, I guess. However, there are some problems with this because of UV light. Because of its wavelength, as you get smaller, it gets more and more messy, I guess. So you have to start using smaller wavelengths, and you do this using smaller beams, such as lasers, and I believe they use electrons as well. And so maybe another concept that they could have shown in the image is that how UV light, as you get smaller and smaller and smaller, gets less precise and specific.
Sorry. It's not supposed to make any noise. Yeah, sorry. Keep going.
And then another concept that we learned in the lab was about resistance. And so I guess a basic definition of resistance is how difficult it is for electrons to move through a wire. And so the thicker the wire and the shorter it is, the easier and faster it is for electrons to go through. And then thinner and longer wires, they go slower because they encounter more resistance. But we couldn't really figure out a way for it to be incorporated well into this image. So, yeah.
Is that it? All right, thank you guys.
Okay, so I'm going to MC the first couple of questions before I have to go to this teleconference so that you get the idea of how you're all supposed to ask questions. But I just want to make 2 points first. So the first one, and I say this to all my graduate students when they're giving talks, so this is for everybody. After you are done talking, say something to the audience like, "Thank you for listening," because the audience is sitting there paralyzed, wondering if you're done, unable to decide whether to clap. So you must say something to them to say, "It's okay to clap now, guys." So it doesn't matter what version of "thank you for listening" you say, but tell them something so you free them from their paralysis. The second thing is just something for everybody for language, which is we give 3 topics that every group is supposed to talk about. So the science, the cartoon, and then every cartoon has a limitation. And so what are the limitations of what this graphical representation is capturing? And it is impossible for any representation to capture all aspects of the science. And it is very interesting to think about what aspects are captured and what aspects are not captured. But just for all of you, and you guys did not do this, don't say, "This is where the picture is wrong," or "This is what they left out." It's not that it's wrong or bad. It's just how far can you take this, glitter glue as an analogy to photolithography, and every analogy has a limitation. So that's what you're supposed to be discussing. But be careful of the language, because it's really easy to slide into, "This is what they left out." And that's not it. That's just the limits of the analogy. Okay, so now, questions for our speakers. Okay, Rita will start the questions, but then you guys will continue, because I won't let the next group go until a parent asks a question.
Okay, so forgive me if you did say this about the UV light and I just missed it, but did you guys think about a way that the UV light wavelength and shortening the wavelength might be represented with glitter as the metaphor? Because I think there is a way actually that you might be able to do that with this photo.
I can't think of it. So if you've got an idea,
Well,
yay for you.
I guess I would think. I guess I'm thinking like, in terms of like the size of the glitter, would that make a difference with patterning here?
What do you mean with the size of
So if you've got a smile that you're trying to do, and if the smile is of a certain size, and you had different sizes of glitter, how would that affect the resolution, and how does that relate to wavelength and resolution for your actual lithography when you're making things smaller and smaller?
Well, I guess if you're using different glitter sizes, you could have gone with the smile, if you use really big pieces of glitter and then you try and make a smile with it, it's not going to come out right. It's going to be kind of splodgy. Versus if you use very small pieces of glitter and then you do the same smile, it's going to come out very well and you'll be able to see it very well defined.
Yeah, I'd agree with that.
Yeah, and that really small glitter is the stuff that gets on your counter and never goes away. that would be X-rays, and the big chunks that are easy to sweep up, those would be visible. So that's the kind of thing, is you could imagine a way to add a concept. Okay, questions from the audience. You're all so hoping somebody else is going to do it. You guys, yes, thank you.
What scale are we talking about in terms of the actual application? What's the size of the circuit?
Can you ask again into the mic?
Sure. What scale are we talking about in terms of the size of the circuits that you could make with this technique?
Well, so basically, the wavelength of light itself is in 400 to 700 nanometers. So we're we're in nanoscience, so we're doing nanometers. Yeah.
So let me just add a couple things. So what was the size of the patterns that you guys made? Do you know? Sort of length scale.
You mean the
Like the width of the wire. You made 2 different wires. Mm-hmm. So what was the width of the wire? Order of magnitude.
I can't remember exactly,
sure.
but I thought it was large enough that you could see it, but it was.
So was it, bigger or smaller than a millimeter? I can't remember what the pattern is.
A little smaller.
Yeah, so a little small, so hundreds of microns, a tiny bit smaller than a millimeter. Mm-hmm. But this is like not a clean room. So now, do you know what are the smallest structures that you could actually make in a super fancy fab, or like the smallest structures that are in your phone? That's what's limited. That's sort of the limiting size.
I'm not sure if I'm remembering this right, but I'm pretty sure you can get it into small, like nanometer size, very, very small.
Yeah, just countable numbers of nanometers, like less than 10 now, I think. So yeah, that's right. Okay, excellent job, guys. Great way to start.